We began this unit by talking about similar polygons, and now we're going to talk specifically about similar triangles. There are a few theorems and postulates we need to know about similar triangles. The first one is the angle-angle similarity postulate, also seen as AA with a similarity sign. It says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. You can see that in the diagram down here. We have two angles congruent to two angles of the second triangle. Therefore, we know these triangles are similar. Similar means same shape, different size. The second one is the side-angle-side similarity theorem, or SAS similarity. It says if an angle of a triangle is congruent to an angle of a second triangle, so down here the two angles are congruent, and the sides that include the angle are proportional, then the triangles are similar. So if we look at these, we have 4 to 8 and 3 to 6. Well, these are proportional because they have a scale factor of 2. So we know that these two triangles are similar by SAS similarity. The last one is the side-side-side similarity, which says if the corresponding sides of two triangles are proportional, then the triangles are similar. So if we look at the smallest side here, 2, to the smallest side here, 6, well, 2 times 3 is 6, so that has a scale factor of 3. 3 and 9 also has a scale factor of 3, and 4 to 12 also has a scale factor of 3, so we know that these two are proportional. Now it can get confusing when we have similarity versus congruency. So for similar triangles, we have the angle-angle, side-angle-side, and side-side-side. Now two of those are repeated in the congruency. The side-angle-side and the side-side-side are also for congruent triangles, so we need to make sure we know if it's congruent or similarity. But then we also have for congruent triangles the angle-side-angle and the angle-angle-side, and lastly the hypotenuse-leg theorem. So there are more theorems that prove triangles congruent than similar, but it's important that we know which one exists for both. Now it's your turn. Determine if the triangles are similar, and if they're similar, justify your reasoning. If we look at the first triangle, we know this is similar by side, side, side. We have 6 to 9, 8 to 12, and 10 to 15. So we took the three sides and put them in order from least to greatest, and we did this with the second triangle, least to greatest, and we compared these ratios. Well, 6 to 9 is 2/3, 8 to 12 is 2/3, and 10 to 15 is also 2/3. So by the side-side-side side-side-side similarity postulate, we know that these two triangles, STU and XVW, are similar. The second one, I apologize that the answer is already up there, but we know these triangles are not similar. Because if we look at the side of the small triangle, it's 8 to the whole side of 12. And then we have 12 to the whole side of 15. These do not reduce to be the same. Excuse me. The first one is 3/4, or 2/3, sorry. And the second one, when we reduce it and we divide by 3, we get 4/5. So those are not similar because the sides are not proportional. And the third one, they are similar by side, side, side. Because if we compare again the two smaller sides, 6 and 6, to the two smaller sides of the second one, 8 and 8, and then we take the 9 to 12, we're going to have the same ratio of 4/3. So ABC is similar to EFG. And the last one, we're going to compare 8 to 16 and 6 to 12. And then we also have a shared angle in the middle. So it would be side, angle, side. And they are proportional because 6 to 12 and 8 to 16 both reduce to 1/2. So ACE is similar to ALW. And I apologize again, the E got cut off in the bottom of our diagram. E would be down here, ACE. And that's it for similar triangles. Bring your questions to class.